Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible, at least to the extent allowed by law, donation to support our program, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam P on probability. Let x1 through xn, with these subscript written in parentheses, that's a standard notation for order statistics, so let these be the order statistics from the uniform distribution on 0, 1. Find the correlation coefficient of x1 and xn. And here is the solution. So it's a little bit of work, but let's do this carefully and consider the question. Again, it's the correlation coefficient that we're looking for. The correlation coefficient of the first and last order statistic in a random sample. If x is uniform on 0, 1, then so is 1 minus x. And the order statistics for a random sample for x are the same as the order statistics for a random sample of 1 minus x, but in reversed order. Well, this means that we have e of x1 equal to 1 minus e of xn, and variance of x1, which is a variance of 1 minus xn, and that's equal to the variance of xn. So they, the first and last order statistic relate in their expected value by e of x1 being equal to 1 minus e of xn, but they have the same variance. Also note that f sub xn of x is x to the nth power of the CDF of uniform distribution, and the reason for that is just straight from the definition of the CDF, of the cumulative distribution function. What is f sub x sub n of x? It's the property that x sub n is less than or equal to x, and that means that the largest order statistic is less than or equal to x, and that means that every single piece of the random sample is less than or equal to x. And the probability that a random number from the uniform distribution on 0, 1 is less than or equal to x is equal to x. So if this happens independently n times, that probability corresponding to the value of f sub x sub n of x is x times x times x n times, and that's x to the nth. That's, again, because of independence of in a random sample. So this is the nth power of the CDF of uniform distribution on 0, 1, so that the survival function is equal to 1 minus x to the nth. And, of course, the random variable considered is non-negative with probability 1, non-negative almost surely. So Darth Vader rule can be used, and we can find the expected value as the integral from 0 to 1, because beyond 1 the survival function is 0, of the survival function. So the integral from 0 to 1 of 1 minus x to the nth dx, and that's n over n plus 1. And that means that e of x1 is 1 minus this, so 1 minus n over n plus 1, and that's 1 over n plus 1. We also have f sub xn of x equal to n times x to the n minus 1, which is the derivative of x to the nth. And therefore the expected value of the square of x sub n, the second moment of it, of the nth order statistic is the integral from 0 to 1 of x squared times n x to the n minus 1 dx. So that's n times the integral from 0 to 1 of x to the n plus 1 dx. And the function whose derivative is x to the n plus 1 is x to the n plus 2 over n plus 2. Evaluated from 0 to 1 gives us 1 over n plus 2. So n times 1 over n plus 2 is n over n plus 2. And this implies that the variance of x sub n is n over n plus 2 minus the square of the expected value, so minus square of n divided by n plus 1 squared. Okay, so we find the common denominator, which is just the product of the denominators, and write this as n times n plus 1 squared minus n squared times n plus 2 divided by, in the denominator we have n plus 1 squared times n plus 2. Well, the top thing actually, the difference of these two expressions is n. So this is n over n plus 1 squared times n plus 2, and that's the variance of xn, but it's also the variance of x1. Now the joint density of x1 and xn, the first and last order statistic, that's related to an interesting question that you probably should study, is what is the joint distribution of two order statistics, any of them. And the method of determining it is the same, more or less, as here. So this is determined by observing that x sub 1 is in x to x plus dx, and x sub n is in y plus dy with x less than y. That if this happens, then n minus 2 pieces of the random sample must be in the interval xy, because everything else has to be between those two, the first and last order statistic. That's the remaining n minus 2 pieces of the random sample. And the probability of that is n factorial divided by n minus 2 factorial, which is number of ways to pick ordered, not unordered, but ordered samples of size 2 from population of size n. Or just note that there were n ways to pick the first number and n minus 1 ways to pick the second one. And that's multiplied by y minus x to the n minus 2, which is the probability of being in the interval xy. Multiplied by dx, which is the probability of being in the interval x to x plus dx. And then dy, which is the probability of being in the interval y to y plus dy. All this because this is a uniform distribution. So again, x has to be less than y. We have to, and so it's ordered, and we pick the first number, x, and then we pick the second number, y, and then everything else has to fall in between. And then we put together these probabilities. Well, given this PDF, what is the expected value of x1 times xn? Well, it's the integral from 0 to 1 of the integral from 0 to y, because x is less than y. So that x is constrained, being less than y, of xy, which is x is the value of x1, y is the value of xn, times that density, n factorial over n minus 2 factorial, times y minus x to the n minus 2 times dx dy. Okay, we take out the part that doesn't have x in it for the integral with respect to x, so that's the integral from 0 to 1 of ny, and inside we have the integral with respect to x, which is integral from 0 to y of x times n minus 1 times y minus x to the n minus 2 dx. And we actually keep that n minus 1 because we're going to use it in this calculation, in this integration by parts. And then we take the integral with respect to y. And for the integration by parts, we take u to be x, then the derivative, no, the differential du is dx. And then what we have there, we make it into dv. So n minus 1 times y minus x to the n minus 2 dx. Well, then v is minus y minus x to the n minus 1. Remember, we taking the derivative with respect to x. So that's why this minus there. So this becomes now, well, we have to do this integral there by integration by parts. So if you take x times, so uv, and evaluate it from 0 to y. At 0, it's 0, and at y, it's also 0. So we can disregard that. So all we have is we'll take minus the integral of v du, and minus minus cancels. So it just becomes the integral from 0 to y of y minus x to the n minus 1 dx. And we can calculate that integral. It's minus y minus x to the nth over n, evaluated from x equal to 0 to x equal to y. So after you do the calculation, this becomes just the integral from 0 to 1 of y to the n plus 1 dy. And that is, of course, 1 over n plus 2, because the function whose derivative is y to the n plus 1 with respect to y is y to the n plus 2 divided by n plus 2. And it's divided by n plus 2 because if you take the derivative, n plus 2 goes in front, and you need to cancel it with, well, it cancels out with the n plus 2. Sorry about that barking in the background. My dog Chesterton was trying to get into the video. So this implies that the covariance is e of x1 xn minus e of x1 times e of xn. And that's 1 over n plus 2 minus n over n plus 1 squared. Okay. And then the correlation coefficient is that covariance divided by the standard deviation of the first thing times the standard deviation of the second thing. Well, they have the same standard deviation, so it's just a variance at the bottom. And so you see this expression. We find the common denominator in the numerator, and we end up with what you see here. And n plus 1 squared times n plus 2 cancels out. And then we have n plus 1 squared minus n squared minus 2n. Well, what is n plus 1 squared? It's n squared plus 2n plus 1, so only 1 is left. So this whole thing is equal to 1 over n, which is answer E. Well, please remember, this is copyrighted material. The problem is created by me, and the solution is created by me. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.